Hello everyone, welcome back to my YouTube channel. In this video, I will explain the first two questions of the EJU's Past Paper Year 2018, second session and course 2. Before I start, please feel free to subscribe my YouTube channel and I hope you can learn something from this YouTube channel. Okay, let's start from number 1. Let us consider the maximum value capital M and the minimum value M of the quadratic function f of x equals to x squared minus 2 times a plus 1 x plus 2a squared over the range of x from 0 until 2 inclusively, where a is a constant and a between 0 until 3 inclusively. First of all, they say the coordinate of the vertex of the graph of y equals to f of x are blah blah blah. So we want to find the vertex of the graph y equals to f of x. If we want to find the vertex of a quadratic equation, the x coordinates of the vertex can be found by using the equation or the formula negative b over 2a. Of course, you can use first derivative to find the x coordinates, but the more simple way is by using the formula negative b over 2a. So x symmetry, this is the x coordinates of the vertex, is equals to negative b over 2a. b is the coefficient of x and then a is the coefficient of x squared. The coefficient of x is negative 2 times a plus 1. Negative 2 times a plus 1 over 2 times a. The coefficient of x squared is 1. 2 times 1. We can cancel out the negative sign. We can cancel out 2 here. And then I got x symmetric is equals to a plus 1. This is the x coordinates of the vertex. So letter A here is 1. After we got the x coordinates of the vertex, how to find the y coordinates of vertex? To find the y coordinates of the vertex, we can simply put this into the equation. If I substitute x into a plus 1, I will get the value of y coordinates of the vertex. So let's substitute a plus 1 to the equations. The equations will become a plus 1 square minus 2a plus 1 times x. We substitute the x by using a plus 1, right? A plus 1 plus 2a squared. A plus 1 times a plus 1, it will become a plus 1 square. And then a plus 1 square minus 2 times a plus 1 square, it becomes negative a plus 1 square. Negative a plus 1 square plus 2a square. Next, I will expand this equation or this expression. After I expand this expression, I will simplify it with 2a square. I will get negative a square plus 2a plus 1 plus 2a square. If we distribute the negative sign into the brackets, I will get negative a square minus 2a minus 1 plus 2a square. And therefore, if we simplify this expression, I will get a square minus 2a minus 1. This is the y coordinates of the vertex. Then letter B and C here is 2 and 1. Letter B is 2, a squared minus 2a, yeah? So the letter B is 2. And then the letter C is 1. Okay, let's move to the next questions. For D until H, in the following sentences, choose the correct answers from the among choices 0 until 9. So this is multiple choice questions. From D until H, we will choose the correct answer here. Let us find the maximum value, capital M. So we want to find the maximum value and the minimum value M according to the position of the according to the position of the axis of symmetry. So we have that blah blah blah. The axis of symmetry is what we already found earlier. This is the axis of symmetry. And then if 0 less than or equals to A, less than or equals to D, then blah blah blah. So I think the first case here is where the axis of symmetry is inside the range of X. I repeat it once again. For this case, I think the range of symmetry, the axis of symmetry is inside the range of X. So A plus 1 must be less than 2 so that it inside the range of X. If I write A plus 1 less than 2, I will get A less than 1. This is the upper limit or the upper boundary of value of A for the first case. So A is 1. I will change the color first. Okay, A is 1. From 0 until 1. Why it is 0 here? Because the smallest value of A is 0. So from 0 until 1, then the maximum value is blah 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 and the minimum value is blah blah blah. Now consider we have a quadratic function with a vertex inside this range. I will sketch it so that it is more clear to see what I mean. This is the range of X from 0 until 2. And then the stationary point or the vertex is inside this range. So my graph or my curve must be something like this. Something like this. The vertex is inside the range of values of X. From this graph, it's pretty clear that the maximum value will be obtained when X equals to 0. And then the minimum value will be obtained at X equals to the vertex. The vertex is A plus 1. We already calculated it earlier, yeah? So when I want to find the maximum value, I will just substitute X equals to 0 to the equation. The equation is Y equals to X squared minus 2 open bracket A plus 1X plus 2A squared. If I substitute X equals to 0, I will get the maximum value, which is 0 minus 0 plus 2A squared. Therefore, the maximum value is 2A squared. This is the maximum value in my first case. 2a squared is on the number 6. So letter E is 6. And then how about the minimum value? If you see from this curve, the minimum value will be obtained when x equals to a plus 1. When x equals to a plus 1, we will get the y coordinates of the vertex. That's the minimum value. The y coordinates of the vertex we already find in our earlier working. So when x equals to a plus 1, the coordinates of y, which is the minimum value in this case, is a squared minus 2a minus 1. So this is a squared minus 2a minus 1. This is the value of m. This is our m. So the minimum value is a squared minus 2a minus 1. And I will obtain this answer in number 5. So letter F is 5. And then let's move to the second case. If D is 1, if D less than or equals to A less than or equals to 3. Why there is 3 here? Because A is between 0 until 3. So the first case, we only see from 0 until 1. So for the next or the second case, I will see from 1 until 3. If 1 less than or equals to A less than or equals to 3, then blah blah blah. The maximum value is blah blah blah, and then the minimum value is blah blah blah. If A is between 1 until 3, so our stationary point or our axis of symmetry is outside or exactly on x equals to 2. I will repeat it once again. If A is between 1 until 3, so our axis of symmetry is outside 2 or exactly at x equals to 2. If I draw a curve, it should be something like this. This is 1 and then this is 2. The axis of symmetry is exactly at 2 or outside. So our graph is something like this. Something like this. The axis of symmetry can be outside of 2 or exactly at 2. From this graph, you can see that the maximum value is at x equals to 0. Oops, sorry. This is 0, yeah, not 1. The maximum value is when x equals to 0. And then the minimum value is when x equals to 2. This is the minimum value. So to find the maximum value, I will substitute x equals to 0. If I substitute x equals to 0 to this expression, of course, I will get the same answer as this. So the capital M here must be the same as the earlier result, which is 2a squared. 2a squared is number 6. So this is 6. And then the minimum value will be obtained when x equals to 2. This is the lowest part of the curve when x equals to 2. When x equals to 2, I will get the value of y, which is, just substitute x with 2. I will get y equals to 2 squared, 4, minus 2a plus 1 times 2 plus 2a squared. If we simplify this expression, I will get 4 minus 2 times 2 is 4, and then distribute the 4 into the bracket. I will get 4a minus 4 plus 2a squared. This is the minimum value of y. This is m. So m is equals to 2a squared minus 4a. This is the answer for letter H. 2a squared minus 4a. 2a squared minus 4a is in the number 8. So letter H is number 8. Okay, next to the last questions. Thus, m is maximized at a equals to blah blah blah, and the value of m then is blah blah blah. Also, m is minimized at a equals to blah blah blah, and the value of m then is blah blah blah. So now I want to find the maximum and the minimum value of m. Maximum and minimum value of m, and its corresponding value of a. m is 5. What is 5? 5 is, let I write down here, a squared minus 2a minus 1. m is a squared minus 2a minus 1 if a is between 0 until 1, and m is also 2a squared minus 4a if 1 less than or equals to a less than or equals to 0. So I will write m as a piecewise function. M is a squared minus 2a minus 1 if a is between 0 until 1, and then m is also equal to 2a squared minus 4a when a equals to 1 until 3 inclusively. To find the maximum and minimum value of m, I will try to sketch the curve of m. So I will try to sketch this. The vertical axis is m, and then the horizontal axis is a. Let's say this is m, and then this is a. And then we will sketch from a from 0 until the maximum is 3. So let us focus on this region only, 1 until 3. From 0 until 1, we will sketch this graph. From this graph, you can find the x symmetry or the axis of symmetry by using negative b over 2a. So from the first one, the x, in this case a, the a sim is negative b over 2a. b is 2, a is 1. Remember, b is the coefficient of a, and then a is the coefficient of a squared. By using this formula, I will get the asymmetry is equals to negative b, which is negative 2, over 2 times 1. Negative times negative 2 is 2. 2 divided by 2 is 1. So on the first curve that I want to draw, the lowest point is at a equals to 1, which is outside our range of x. The lowest point is when a equals to 1, but 1 is not included in the range. 1 is not included in the range. So if I want to sketch this, I will just substitute a equals to 0. When a equals to 0, you will get m equals to negative 1. And then the graph will go down like this. Will go down like this. Because it's parabolic, yeah? Since it is quadratic equation, the shape of the graph will be parabolic. So the graph will be go down something like this. And then for the second one, the stationary point or the x-axis, the symmetrical axis of x, we can also found by using the same equation. Asymmetry is equals to negative b over 2a. Negative b is negative 4, over 2 times a. A is 2. 2 times 2. We will get asymmetry is equals to 1. 1 is in the range of a. So when a is equals to 1, if you substitute into this equation, 2 minus 4, you got negative 2. You got negative 2. So when a equals to 1, the value of y or m is negative 2. I will assume it should be something like this. It should be something like this. Sorry. This is negative 2. There is negative 2. Let us check where this point n. What is the value of m when a equals to 1 on the first equation? 1 minus 2 minus 1. Oh, it's also negative 2, yeah? So I think it should be something like this. Negative 2 is here. Since this is the vertex of the second graph, this is the lowest point of the second graph. If I substitute a equals to 3 into this equation, I will get 2, 3 square minus 4 times 3. 3 square is 18, is 9. 9 times 2 is 18, minus 4 times 3. 4 times 3 is 12. It becomes 6. So when a equals to 3, the value of m is 6. Let's assume this is 6. So the graph should be something like this. This is the graph of this piecewise function. And from this graph, it is pretty clear that the minimum value is when a equals to 1. So m is minimized when a equals to 1. And the value of m then is negative 2. This is negative 2. And then the maximum value of m is when a equals to 3. And then the value of m then is equals to 6. This is the answer of the first questions. Okay, let's move to the next questions. The next question is talk about probability. Let us throw one dice 3 times. So we will throw one dice 3 times. And let the number that comes up on the first throw be A. The first throw is A. The number comes up is A. And then the numbers comes up on the second throw is B. And then the number that comes up on the third throw is C. Using this A, B, and C, we consider the quadratic function f of x equals to ax squared plus bx plus c. the probability that b equals to 4 and that the quadratic equation f of x equals to 0 has two different real solutions is blah blah blah. They already tells us that b is equals to 4. So our quadratic equation will become ax squared plus 4x plus c. And then if I equate this with 0, I will get the quadratic equations, and then I want this quadratic equation has two different real solutions. The condition that must be satisfied for a quadratic equation to has different real solutions, to has two different real solutions is the discriminant must be greater than 0. The formula of discriminant is b squared minus 4ac is greater than 0. b is 4, 4 squared is 16, minus 4 times a, we still do not know the value of a, so just write it as a, and then times c. We do not know the value of c, so I will write it as c, greater than 0. If we move the 16 into the the right hand side, we will obtain negative 4ac greater than 16, negative 16 I mean. And then if I divide both sides by using negative 4, I will get ac. Since we divide it by using negative number, the sign of the inequalities must be changed. AC less than 4. This is the condition to determine the value of A and C. To determine the value of A and C. If the value of A is 1, I will write it here. This is A, this is C. If the value of A is 1, then the value of C must be either 1, 2, or 3. Remember, A, B, and C are the number that comes up when we throw a dice. So A, B, and C is between 1 until 6. Because one dice has 3 faces. Number 1 until number 6. So if A equals to 1, then C is either 1, 2, or 3. So that A times C is less than 4. And then the other case is if A equals to 2. If A equals to 2, so C must be 1. There is no other possibility. Because if C equals to 2, 2 times 2 is not less than 4. And then the other case is A equals to 3. If A equals to 3, then C is 1. C cannot be 2 because 3 times 2 is not less than 4. This is our cases. And then B must be 4. So if I put one more column here, this is B. B must be 4. After I got this table, I can find the probability. What is the probability A equals to 1? It is 1 over 6. When we throw a dice, what is the probability? What is the probability that 1 is coming up? That is 1 out of 6. Times C can be 1, 2, or 3. So there are 3 possibilities for C. So the probability C is 1, 2, or 3 is 3 out of 6. And then B must be 4. The probability that B is equals to 4 is 1 out of 6. If we apply to the next or the second and the third row, I will get 1 over 6 times 1 over 6 times 1 over 6. And then the last row is also 1 over 6 times 1 over 6 times 1 over 6. This is 3 over 216. This is 1 over 216. This is also 1 over 216. Then the total probability is, we just add it up. 3 plus 1 is 5 out of 216. This is the answer for N, O, P, and Q. N is 5, O, P, Q is 216. Next, let us find the probability that f of 10 is greater than 453 is as follows. They help us with the possible case. F of 10 is greater than 453. F of 10 is greater than 453. F of 10 is a times 10 square. F of x is ax squared plus bx plus c, yeah? So f of 10 is a times 10 square plus b times 10 plus c is greater than 453. 10 square is 100. 100 times a is 100a plus 10b plus c greater than 453. Remember that a, b, and c is between 1 until 6. A, B, and C is between 1 until 6 inclusively. And A, B, and C is an integer, because we talk about number that comes up when we throw a dice. The first case is when A equals to 4. When A equals to 4, it means 400. B equals to 5 plus 50. It is R. It is R. How many cases there? When A equals to 4, B equals to 5, C can be 4, 5, and 6. So that if we add it up, it's greater than 453. C is either 4, 5, or 6. So there are 3 cases. This is R. And then when A equals to 4 and B equals to 6, if I use the same method, 400 plus 60 plus, how many cases are C? 400 plus 60 is already 460. It's already greater than 453. So C can be 1, 2, 3, 4, 5, and 6. No matter what is the value of C, if we add it with 460, it will greater than 453. So when A equals to 4 and B equals to 6, it is 6 number of the cases. And then how about if A is 5? If A is 5, I got 500 plus B plus C plus 10 times B plus C. Since 500 is already greater than 453, I mean, so B and C can be any number. So B can be from 1 until 6, and also C is from 1 until 6. There is 6 possibility for B and 6 possibility for C, so the total cases is 6 times 6. It is 36. The same things happen when A equals to 6. Since 6 is already greater than 453, 6 times 100 is 600. It's already greater than 453. So B and C can be any number from 1 until 6. Once again, B can be 1 until 6, there is 6 possibility, and C also 1 until 6. Therefore, it is 36 cases. Hence, the probability that f of 10 is greater than 453 is blah blah blah. What is the probability that f of 10 is greater than 453? Since we already know there are 3 plus 6 plus 36 plus 36 cases, so the probability is the number of cases divided by the total number of cases, or the total, the sample space. If we throw a dice 3 times, then the sample space is 6 times 6 times 6. If we have 2 dice, or we throw a dice twice, the sample space is only 6 times 6. So if we calculate this, 36 plus 36 is 72, 72 plus 9 is 81. 81 over 216, it will become 3 over 8. This is the answer for letter X and Y. Okay, this is the end of this video. I really hope you guys can understand what I already explained in this video. Thank you for watching this video, and see you guys on my next video. Thank you and bye-bye.